Here we are for problem number 38 from chapter 7. If you lift the front wheel of a poorly maintained bicycle off the ground and then start it spinning at 0.72 revolutions per second, friction in the bearings causes the wheel to stop in just 12 seconds. If the moment of inertia of the wheel about its axle is 0.3 kilogram meters squared, what is the magnitude of the frictional force? So the first thing we need to do before we get started is we need to convert this initial rotational velocity from revolutions per second to radians per second. And the way you do that is just by saying that one revolution is equal to 2 pi radians. And that gives you an angular velocity of 4.52 radians per second. Now we can go about solving the problem. So they ask us to find the torque. So one thing we could start with is just that torque is equal to I alpha. And by doing that, we know that the moment of inertia they tell us is 0.3 kilogram meters squared. I wrote that incorrectly over here. Make that change real quick. Okay, but we don't have alpha. Luckily, we know how the angular velocity changes over time. So we can go to one of our kinematic equations that has been converted to angular motion. And we can say then that omega sub f is equal to omega sub I plus alpha t. 0 is equal to 4.52 plus alpha times 15, 12. And by solving for alpha, we get that the acceleration, the angular acceleration, is going to be 0.377 radians per second squared. Putting that over here, 0.377. We find that the torque applied to that wheel is going to be minus 0.113 Newton meters. That is problem number 38 from chapter 7.